Okay, chapter 26 is your parenteral doses using ratio and proportion calculations. So you're a little bit familiar already with the ratio and proportions formulas. So this is going to be adding the parenteral doses and inserting those into those formulas. So after you read through chapter 26 and do some of the simple problems, the student should be able to describe 3 parenteral routes of administration, define your IV, which is your intravenous, IM, which is your intramuscular, and your SC, which is their subcutaneous. Um, Calculate parenteral doses using ratio proportion. So pharmacy technicians prepare parenteral medications for use in hospitals, home health care, and long-term care. Your parenteral medications are medications that are injected into the body by different routes, such as intravenous, intramuscular, and subcutaneous. Your parenteral medications are available as liquids and as powders. A drug in a powder form must be reconstituted before it can be injected. The strength or concentration of a medication is usually expressed as a measurement of weight. Usually that weight can be in like milligrams, grams, or units. So in a specific volume, such as milliliters or cc's, and remember milliliters is always the same as cc's. For example, it could be they could be referring to 250 milligrams per milliliter. And remember, when you see that, you always assume 1 over here. Okay, so it'd be, if you wanted to set it up, okay, so it's the same thing as this. Also, of course, you could have, you may say like 10,000 units. And of course, they say to always write out the units, not to abbreviate, but just for the speed of the course of me going through the calculations, I'm going to probably abbreviate those. Okay, per 2 cc's. Calculations, of course, must be made to convert the measurement of weight ordered by the physician into a volume. Different size syringes are used to measure this volume for injection, either into the patient or into a solution bag for infusion into the patient. So, in pharmacy practice, milliliters and cubic centimeters are always considered interchangeable. So if it says 2 cc's, it also means 2 milliliters. Okay, so we're going to go ahead and start reading through some of these problems, and I'll start, of course, on page 207. Okay. So I'll do number 1. If you look in your book, I'm not going to write the question out here. But a TPN, which is a total parenteral nutrition, requires the addition of 15 units of regular insulin, U100. A 10 milliliter vial of insulin contains 1,000 units. So how many milliliters of insulin should be added to the TPN? So I always tell people, remember one side that you have both numbers is going to be what you have in stock or what you know. Okay, so the first part would be, you have a 10 milliliter vial of insulin that contains 1,000 units. It don't matter if you put 10 milliliters on top or 1,000 units on top or vice versa, as long as when you cross multiply, and I will abbreviate units U. Okay. Whenever you multiply the X by, always goes on the bottom. Okay. Okay, so over here, if you know, it's asking how many milliliters of insulin. Okay, so we know we have milliliters on top, so we're going to put the X ml here because you have to have both liquids on top. You can't have a milliliters and a milligram. Okay, you have to have both liquids on the top here, and then because in some cases it may be milliliters on one side and liters on the other, and you have to convert. But for this sake, you just have to set it up with the liquids on top. And in our case, we're lucky, and then both of them are milliliters, so we don't have to convert anything on top. Okay, but it requires the addition. If it says that the TPN requires the addition of the 15 units of regular insulin, U100. So that's when it's comparing it by. So it's 15 units. Okay. So then we're going to cross multiply. Remember, whatever you multiply the X by, always goes on the bottom. So you have 1,000, and I always tell people just to, I'll have it just so you remember that 1,000x. 10 times 15, excuse me, yeah, 10 times 15 would be 150. So then you divide 150 to 1,000 and you get 0.15 milliliters. Okay, so your 0.15 milliliters out of 15 units. Okay. Number 3, I'm going to do several of those just because they're easy to do here. So 3A, there's not much right. I'm going to write it out for you here. 25 milliequivalent, and I'm going to abbreviate potassium chloride. And it tells you automatically that your stock is 2 milliequivalents per milliliter of KCl, potassium chloride. Okay, so what you want to do is you want to set it up. And you know your stock is what you're going to have on one side. Okay, so we're going to put 2 milliequivalents per 1 milliliter. Okay, and over here is what you're trying to find out. So in how much? So it's 20, you know, you have the 20, you need 25 milliequivalents, and you're trying to find X milliliters because the question said calculate the number of milliliters required to prepare the following concentrations, and then it gives you several of them. Okay. So now we're going to cross multiply. Whatever you multiply the X by always is on the bottom, so that would be 2. 25 divided by 1, or times 1. Of course, it's 25. 25 divided by 2, you should come up with 12.5 milliliters. Three B. If you, and I'm not going to write the problem up here, but you know, of course, you have 37, you need 37.5 milligrams of a medicine. Of course, the stock is 50 milligrams per 2 milliliters. So our stock is going to go on this side, 50 milligrams per 2 milliliters. And you need 37.5 milligrams, and we're trying to determine the number of milliliters required for the 37.5 milligram. You cross multiply, whatever you multiply the x by goes on the bottom, so it'd be 50x. Then you have 37.5 times 2 is going to equal 75. You divide that and you come up with 1.5 milliliters. Three C, you have, of course, your stock is your 50 milligrams per 1 milliliter, and you're wanting 1,050 milligrams. Okay, and then of course you're going to have X milliliters here. So you're going to cross multiply. Whatever you multiply the X by always goes on the bottom. So 50 times X is 50. 1,050 times 1 will be 1,050. Divide that, and you get 21 milliliters. Okay, next on 3H, we're going to skip down a few because this one's a little bit different. You have units. So you have your penicillin units. So what you have on hand or stock is 500,000 units per 1 milliliter. And you want to know how many milliliters you need for 200,000 units of your penicillin. You're trying to find X milliliters. So cross multiply. Whatever you multiply the X by always goes on the bottom. So it's 500,000 200,000 times 1, 2,000. And just so you don't have to keep putting a bunch of numbers in the calculator, we're going to, if you have 5 zeros here, you can mark those out, 5 zeros here. Okay, so it have to be the exact ones to cross them out. Then 2 divided by 5 is 0.4 milliliters. Okay, now we're going to do one that we have to convert, so I'm going to write it up here. Number 4. So if there is 20 milligrams of a drug in 10 milliliters, of solution, and we'll abbreviate that, how many liters of solution will contain 1 gram of the drug? Okay, so we're going to do the same thing. We're going to set up exactly what we know we have, or what's in stock. So we know we have 20 milligrams of a drug in 10 milliliters. Okay, and we know we're trying to find X liters. So I always go ahead and we've got to put it with the liquids. So you have liquids on the bottom here. So we're going to put X liters. Okay. That will contain 1 gram of a drug. So you have weight up here at the top, so weight will be up here. So if you notice, on the top we have liquids, but they're not the same unit. So we have to make them the same. So in order to convert, you just have to do you could do your little pretty cross if you wanted to and do the conversions. But anytime, remember I told you that one chart, if you remember 1 gram equals 1,000 milligrams, so you could go ahead and almost calculate in your head. So you know if you're going from grams to milligrams, you just multiply it by 1,000. So you, 1 times 1,000 would be 1,000, and that would be milligrams now. Okay, now over here, you're going, of course, into from milliliters to milliliters, and you need to make it liters because you're finding X liters, so this has to be changed to liters. Okay, so then you could, down here, if I know on this one you divide by 1,000, but if you forgot how to do that, just memorize it. So do your cross, 10 milliliters. You have milliliters here, you have milliliters here, and liters. And just remember 1 liter is equal to 1,000 milliliters. So that'd be 10 divided by 1,000. Okay, and then you come up with 0.01. Okay, so that would go here. Okay, so then I'm going to just kind of mark these out just so it doesn't confuse me. Okay, so we'll cross multiply 20 divided by X, it goes on the bottom. Then you have 1,000 times 0.01 is going to equal 10. 10 divided by 20 would be 0.5 liters. Okay, next you have number 7. That's another easy one, so I'm not going to write up the thing. So number 7, elixir of oxygen contains 50 micrograms per milliliter. How many micrograms are in? 0.3 milliliters of the solution. So we know we have on stock 50 mcg over 1 milliliter. And we're trying to find X micrograms in 0.3 milliliters. So then you're going to cross multiply. X times 1 will go on the bottom, would be 1. 50 times 0.3 would be 15. So your answer would be 15 micrograms. Okay, number 8. A physician orders 25 milligrams of theophylline to be given orally to a pediatric patient. If the elixir of theophylline contains 80 milligrams per tablespoon, how many milliliters should the elixir should be administered? So we know we have 80 milligrams per tablespoon. We're trying to find X milliliters, so we always put it with our tablespoon is liquids. So we put our X milliliters down here. And of course, the physician orders a 25. So we're trying to find out how many milliliters we need for the 25 milligram of theophylline that the doctor ordered. Okay. So then you cross multiply. Whatever you multiply the X by always goes on the bottom. So 80 times X would be 80. Put X there if you want to. 25 divided, so now we got a thing here. Double check our things here. So milligrams, tablespoons, milliliters. So we have liquids on the bottom, but we need to convert our tablespoons to milliliters. Okay. So we know 1 tablespoon is equal to 15 milliliters. Okay. So 15 times 25 would be 375. Okay. So 375 divided by 80 should come up with 4.68, and we round it to 4.7 milliliters. So anything larger than a 5, we make that one go up, and we drop this one. Okay, so I'm going to do number 10. Trying to decide which one I wanted to do. I'm going to do this as my last one. I want to do one where you have to convert again. So I'll write this one out. A physician orders 0.4 milligrams of a drug. The label on the vial states that the concentration is 500 micrograms per 2 milliliters. How many milliliters of the drug should be dispensed? Okay. So if we look at here, we know what we have is 500 micrograms per 2 milliliters. So we're going to put it in as what we know. We found to find X milliliters, so how many milliliters? So we have liquids on the bottom, so we're going to put it down here. And then, of course, that's out of 0.4 milligrams. Okay, so we're checked down here. We have milliliters here, same units. Up at the top, we have milligrams and micrograms. Okay, so we need to change this micrograms to milligrams. Okay, and so in order to do that, we have to convert our 500 micrograms to milligrams. Okay, so if you have micrograms here, micrograms goes here. And remember, our chart, you have 1,000 milligrams equals 1 million micrograms. So if you wanted to, you could just to keep you from having to put so many zeros in the thing. You have 3 zeros down here, 3 up here is the same. Okay, so then it's 500 divided by 1,000. So you should come up with 0.5. Okay. So now it's 0.5 milligrams. I'm going to erase this off here so I have more room. Okay, so then you're on to, I'm going to change colors, cross multiply 0.5 times x is going to go on the bottom. 0.4 times 2 is going to be 0.8. You divide 0.8 by 0.5 and you get 1.6 milliliters. So as you're doing these formulas, just remember, you know what you have in your stock is going to be on one side and what you're trying to find on the other and what the doctor's ordered, okay, on the other side. Always double check your units to make sure you have weights on the top. Make sure those weights are the exact same unit. If they're not, you need to convert one to make it correct, okay? Same on the bottom. Good luck. If you have any questions, just send me an email.